Okay, today we are looking at our new unit, Chapter 9, so we're starting to look at trigonometry. So we're going to start with a little bit of integrated algebra review. So let's dive right in. Find x and state the three trig functions of angle B for each of the following triangles. So to find x, you should remember to use the Pythagorean theorem. A squared plus b squared equals c squared. And so that would be 3 squared plus 4 squared equals x squared. So 9 plus 16 equals x squared. So 25 equals x squared. So x should be plus or minus the square root of 25, which is 5. But we're talking about a triangle, so x is going to be 5. First part done. Then it says state the three trig functions of angle B. So here's angle B, and you should remember that the sine of B is equal to opposite over hypotenuse, and the opposite is the 4 to angle B, and the hypotenuse is the 5, and the 3 is the adjacent. So sine of B is equal to 4 over 5, 4/5. The cosine of B is equal to the adjacent over the hypotenuse. That is 3 over 5. And the tan of B is equal to the opposite over the adjacent, which is 4 over 3. On the next one, I'm going to do the same thing, but now I have a squared plus b squared equals c squared. I would have x squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169. Subtract 25, and we get x squared equals 144. And then x would be plus or minus 12, but we're going to just use 12. So now I am talking about B, and now the 5 is the opposite. The 13 is the hypotenuse. The hypotenuse is always opposite the right angle, and the 12 is now the adjacent. Adjacent means next to, opposite would be across from. So the sine of B would be equal to the opposite over the hypotenuse, which would be 5 over 13. The cosine of B would be the adjacent over the hypotenuse, which is 12 over 13. And the tangent of B would be the opposite over the adjacent, which would be 5 over 12. Okay. We'll do a couple from below. Write an equation that could be used to solve for x, then solve the equation, and it tells us what to round them to. So I should be looking at the angle first, 51 degrees, and I should then say, okay, the x is what? Is it an opposite or an adjacent or a hypotenuse? It's an opposite. And the 9 is what? Is that an opposite, an adjacent, or a hypotenuse? That is an adjacent. And then you should remember tan is equal to opposite over adjacent when you're setting up. So we should say then that the tan of 51 is equal to the opposite over the adjacent, which is x over 9. And so there's my equation that I could use to solve for x. Then to solve it, I'm just going to cross multiply here. So I get x times 1, and then it's 9 times tan 51. You do not want to do tan 51 times 9, because then that turns into sometimes an issue with parentheses. Now you want to make sure when you calculate this that your calculator is in degree mode. Okay, so we need to see mode in degrees. So when I go to my calculator, I am going to be typing mode, and I'm in radians, so I'm going to change that to degrees. second mode to quit. Might as well clear that. I'm going to do 9 times tan 51. And you should get that value. So to the nearest hundredth, that should be 11.11. So it's 11.1140. So we would say that x is approximately 11.11 because it said to the nearest hundredth. All right, on the next one, I'm going to circle the 41. And again, look here. The x is opposite the 41. And the 53 is adjacent, but because it's opposite the right angle, it's a hypotenuse. So which trig function would we work with that has an opposite and a hypotenuse? That would be sine. So the sine of 41 should equal x over 53. So that's the equation. And then I'm going to, again, cross multiply and get x equals 53 sine 41. And I'm going to do the same thing in my calculator. I'm just going to tell you that it turns out to be 34.77. So x is approximately 34.77. On C, I am going to, again, circle my angle and look at my pieces. So this is now an adjacent, 14. It's not opposite, it's next to it. And then this is a hypotenuse. So now this one's going to be working with cosine. So the cosine of 73 equals 14 over x. Now when we cross multiply this, we get x cosine 73 equals 1 times 14, or just 14. So this is different. So now we have to divide both sides by cos 73. So x is approximately equal to 14 divided by cos 73. So that's going to be 14 divided by cos 73. And I get 47.8842. So 47.884 would be 0.88 to the nearest hundredth. All right, next we'll take a look at finding some angles. So let's go to E. So on E, I'm looking for x. So again, it's an angle now. So I'm going to look at what I'm given. So again, I have an opposite and I have an adjacent. So that tells me I need to use tangent. So I would say tan of x, because you always do the angle, equals the opposite over the adjacent. Now, to solve this, you want to go second tan on your calculator. And then you want to put in 20 divided by 20 and see what comes up. And that is the measure of your angle x. So angle x would be what? So let's take a look. So I'm going to go second tan. And it's expecting something. It can be a decimal or a fraction. And there it is, 45. Remember, you're in degree mode. So the measure of angle x is 45 degrees. So I put a little lowercase m, angle symbol, x. And this was exactly equal to 45, not approximately. Okay, the next one that we're finding an angle on is H. So let's take a look at that. So now again, I have an opposite. And it looks like an adjacent, but it's across from the right angle, so it's a hypotenuse. So I'm going to be working with sine this time. So sine x is equal to opposite 27 over hypotenuse 80. So I'm going to go second sine 27 divided by 80. And that will give me the measure of my angle. Okay. So second sine 27 divided by 80. So 19.7246. And the directions up at the top say to round the angles to the nearest degree. So the measure of angle x is approximately 20 degrees. So just to, talk about this, if you took an opposite and a hypotenuse that were equivalent to about 27 over 80, but different fractions, the measure of angle x would always be 20. So if you took like a multiple of 27 and a multiple of 80, you're always going to get this angle to be 20. So let's go on to the next page. Okay, so next page, there we go. We are going to be looking at some more of this, the trig functions, and then some angle of elevation and angle of depression. So let's begin. So label the right triangle with vertices ABC, legs, and hypotenuse. So it doesn't matter how you do it. I did A, B, and C like that. Capitals. That's important. Now, to label the sides of triangles, you need to go to the opposite. The opposite of angle A, that is called side A. The opposite of angle B, that is called side B. And the opposite of angle C, that is called side C. And they're lowercase letters. So which side is opposite from angle A should be lowercase a. Which side is adjacent to angle A should be lowercase b, because C is always the hypotenuse. So then it says find the following trig ratios. So first I'm working with A, so I'm going to mark it. And then remember, sine of A is equal to opposite over hypotenuse. So currently right now, my opposite side is here, my hypotenuse is here, and my adjacent is there. So the sine being opposite over hypotenuse would be A over C. The cosine of A, which is adjacent over hypotenuse, would be B over C. And the tangent of A, which would be opposite over adjacent, would be A over B. Now I'm going to mark this up because I'm no longer going to be talking about angle B or A. I'm going to be talking about angle B. So now I'm going to actually change that color. So I'm talking about angle B. So now this is no longer the adjacent and the opposite. Now this is the opposite. And this is the adjacent when I change the letters. Hypotenuse is still the same. So the sine of B is still the opposite over the hypotenuse. So it is going to be now B over C. The cosine of B is going to be A over C because it's equal to adjacent over hypotenuse. Tan B is opposite over adjacent, so tan B is going to be B over A. So on these I kind of wrote them a little backwards, so there we go. Okay, for each problem below, find sine, cosine, tan, and the measure of angle A given. Okay, so here we go. And here's talking about how what you use to find an angle, sine to the -1, second sine, second cos, second tan on your calculator. So we remember sine of A is equal to opposite over hypotenuse, cosine's adjacent over hypotenuse, and tan is opposite over adjacent. So if we're going to set up a triangle of 9, 40, 41, then I just labeled it A, B, C like this because it said make B the right angle. And then A and C doesn't really matter, but you should probably copy what I did. We have to have 41 as the hypotenuse because the hypotenuse is always the longest side. And then it really doesn't matter where you put the 9 and the 40. I just chose those. The answers are going to come out the same. So then it says choose ratio. So for each problem below, find sine, cos, tan of A. Okay, so I'm going to mark off A, and then I'm going to, look at the 40 from the A, that's the opposite. The 9 is the adjacent, and the 41 is the hypotenuse. So I would like the sine of A, which is opposite over hypotenuse. So that's going to be 40 over 41. I want the cosine of A. That's going to be adjacent over hypotenuse, which is 9 over 41. And the tangent of A is going to be the opposite over adjacent, or 40 over 9. The second part says then, remember to find an angle. So you can choose any one of these to find it. So in one instance, I would do second sine, 40 over 41, or you could do second cos of 9 divided by 41, or you could do second tan of 40 divided by 9. They should all yield the same answer. So if we go to our calculator, second sine of 40 divided by 41, you get 77. If I do second cosine of 9 divided by 41, I also get 77. So second tan of 40 divided by 9, you're also going to get 77. They should all be the same. So then, you know, any one of them is approximately 77 degrees. So that's why I said you only needed to choose one. So the measure of angle A is approximately 77 degrees, rounded to the nearest degree. Okay, next for B, if you put radical 3 in your calculator, it's about 1.73. If you put 2 radical 7 in your calculator, it's about 5.29. So that tells you 2 radical 7 needs to be the hypotenuse. So this is 2 radical 7, and then again, it doesn't matter where you put the radical 3 and the 5. And then we're ready to set up sine of A. So we need an opposite to angle A, which would be over here. We need an adjacent, which would be the radical 3, and we need a hypotenuse. So sine is opposite over hypotenuse, so this is going to be 5 over 2 radical 7, and I'm just going to quickly rationalize that denominator and get 5 radical 7 over 14. The cosine of A is an adjacent over hypotenuse, so that's going to be radical 3 over 2 radical 7. Rationalize the denominator, and I get radical 21 over 14. And then the tan of A is opposite over adjacent, so that's 5 over radical 3. Again, rationalize, so I get 5 radical 3 over 3. So now you see kind of why we needed to learn how to deal with radicals. Now, to find the angle, I'm going to use the tangent one. So I'm going to do second tan of 5 divided by radical 3. You don't have to do 5 radical 3 divided by 3. You can use the original. And when I did that, I got the measure of angle A is approximately 71 degrees. So I'd second tan that. All right, next page. We're going to be talking about a 30-60-90 triangle and 45-45-90 triangle. So if you think about a 30-60-90 triangle, well, actually, let's take a look at the equilateral first. You should know that these angles in here are 60, 60, and 60 if it's equilateral. So then if I take and I draw down an altitude, okay, so that turns into 90 degrees, then this angle in here should be 30 because it's equilateral. It should bisect that angle. And so this little length here should be 4. Okay, so really what our triangle looks like is, okay, and I'm going to call this D. So there's D, There's B, and there's A. This was 4. This was 60. This was a right angle. This is 30, and that's 8. So here's your 30, 60, 90, but we need to find the length of BD. So I did 4 squared plus BD squared equals 8 squared. I did the Pythagorean theorem, and so we get 16 plus, I'm just going to call that x now. So x squared is 64 minus 16, which is 48. And then, so x is equal to the square root of 48, which actually simplifies to 4 radical 3. So this value here is 4 radical 3. So now I can take a look at these angles. Okay, so what I'm going to first start off with is the sine of 30. The sine of 30 is opposite, in this case, so here's your opposite, here's your hypotenuse, and here's your adjacent. So to fill in this chart, the sine of 30 is 4 over 8. But what we want to do with that is we want to simplify that. So we get 1/2. Because this is going to occur no matter what equilateral triangle you use. If you use sides of 4, 4, 4, 8, 8, 8, 12, 12, 12, 10, 10, 10, whatever. Now, let's keep going. The cos of 30 is adjacent over hypotenuse, so that's 4 radical 3 over 8. And then we're going to simplify 4 over 8 to 1/2, so this turns into radical 3 over 2. And then tangent of 30 degrees is opposite over adjacent, so that's 4 over 4 radical 3. 4's cancel, you get 1 over radical 3, and if you rationalize that, you get radical 3 over 3. So that's for 30. Now I'm going to go to a different color because now I'm going to go to 60, so I'm going to mark this one off. So the adjacent and the opposite change now. The 4 radical 3 now becomes the opposite. The 4 becomes the adjacent. So now I'm going to do the sine of 60 is 4 radical 3 over 8, and that we already saw. That's radical 3 over 2. Then I'm going to do the cosine of 60. That's going to be 4 over 8, which is 1/2. You should notice some patterns there, similarities. And then the tan of 60 is going to be 4 radical 3 over 4, which just turns out to be radical 3. So those are 30 and 60 for sine and cosine and tan. Now let's take a look at the isosceles right triangle with a 45, 45, 90. So if two sides are 4, to find the missing side, hypotenuse, I would do 4 squared plus 4 squared equals x squared. So that's 16 plus 16, which is 32. So x is equal to radical 16 and radical 2, which would be 4 radical 2. So this is equal to 4 radical 2. So a little thing about the 30, 60, 90 triangle. If the side opposite the 30, okay, is 4, then, you know, this side that's a hypotenuse is twice that. So if the side opposite the 30 is x, then the hypotenuse is 2x. And then if the side opposite the 30 is x, then the side opposite the 60 should be x radical 3. And we can look and compare that to, you know, 4, 8, and 4 radical 3. Now on the 45, 45, 90, the opposite sides to 45 degrees would both be x, and then the hypotenuse is going to be x radical 2. So don't have to just necessarily work with 4s and 8s. So the sine of 45, all right, so now I can just work with one angle, it doesn't matter. The sine of 45, this is the opposite, hypotenuse. There's your, I'm sorry, I got that backwards. This is your hypotenuse, this is your adjacent. So the sine of 45 is 4 over 4 radical 2. And again, that's 1 over radical 2, and then you rationalize the denominator, you get radical 2 over 2. The cosine is the same thing. Because the adjacent and the hypotenuse. And then the tan is 4 over 4. So this one's just 1. Okay? You're going to be using that chart a lot later. And the last two things to talk about are the angle of elevation and the angle of depression. So if you're like looking here, here's your like line of sight. Okay. The angle of elevation is the angle that's formed by a horizontal, and then you'd be looking up. So this is the angle of elevation. The angle of depression is formed if you're standing up here and looking up at something. But it's not the looking down, it's the horizontal to looking down. So this is the angle of depression. It is never this angle up at the top here, okay? So it is never this angle up there. No. No, it's not that angle. So what we say then is the angle of elevation equals the angle of depression. If you take two parallel lines cut by a transversal, the alternate interior angles are congruent. So that's why those are congruent. Last two, an access ramp reaches a doorway that is 2.5 feet above the ground. So if the ramp's 10 feet long, what's the sine of the angle that the ramp makes with the ground? What is the angle? So to draw this, I would assume that this would be the ramp, which is 10 feet long. And it is reaching a doorway, which is, so this distance over here is 2.5 feet above the ground. And then what is the sine of the angle that the ramp makes? So I'm going to introduce you to a new angle. So the angle is going to be a little circle with a line through it, and that is pronounced theta. So I'm going to call this angle theta. That's the one we're looking for. That's used a lot. It's a Greek symbol. So the sine of theta is 2.5 over 10, which is multiplying both of them by 10, 25 over 100, or 1/4. So then if I want to know the angle, I just did second sine. Okay, so second sine of 1 divided by 4. And when you do that on the calculator, the measure of angle theta is approximately 14.48 degrees. So approximately 15 degrees. It depends on what they didn't tell us what to round it to. Last one, from the top of a lighthouse, 75 feet high. Okay, so I'm going to have my lighthouse here, which is 75 feet high. The cosine of the angle of depression. Okay, so the angle of depression, of a boat out at sea. So I'm going to put my little boat out at sea over here. Okay, so here's, the angle of depression. But it's equal to the angle of elevation. So this value up here and this value down here are the same. I call them both theta. So I really want to use the one that is inside the triangle, so I'm going to use that angle of elevation. It's the same as the angle of depression. And the cosine of theta, which I don't know, I know is 4/5. They tell me that. So I'm going to do second cosine 4 divided by 5 and get the measure of my angle. And so theta is 36 point, I don't want to round, 867.89765. Because now I know that angle, and they also said how far is the boat from the base of the lighthouse. So here's my x. So I know that I have an opposite and an adjacent, so I can use tan. So the tan of 36.867.89765 should equal 75 over x. Okay, so I used that angle that I found. So I'd get x times tan of 36.867 equals 75 times 1, and then I would divide that on both sides. so let me show you how you would do this in the calculator. So x turns out to be actually it's exactly equal to 100 if you do it correctly. So let me show you that, and this will end it. So what you should do is the second cosine 4 divided by 5 and get that angle. And then just keep that. Don't clear your display. And then we want to do, we wanted to do 75, we look back at our equation, divided by the tan of that angle. So you just do tan of second negative, and it remembers that big long decimal, and there's no rounding, and then your answer will be exact what it's supposed to be, and when you hit enter, you get 100. You don't get like 99.999 or whatever. You actually get what you're supposed to. So that's how I got it. All right, sorry it was long. All right.